So let's talk some about their properties. Here's a picture taken by the Hubble Space Telescope of some galaxies. You'll notice that there's a big yellow one in the kind of center left. There's a bluish spiral in the lower right. There's some big galaxies, some small galaxies, some that have definite spiral shapes, some that don't have definite shapes. What are the differences between these? What differences are important? What differences are telling us something fundamental? And which ones are randomness? So we'll start with the simplest looking galaxy, and that's an elliptical galaxy. Elliptical galaxies tend to be round, not necessarily circular. They can be oval shaped, but they're fairly round. They have very few features, very little dust, if any dust, very little gas, if any. And mostly they're just starlight. So here's an elliptical galaxy called Messier 87, and you look, it's round, it's yellow, it's kind of boring. The yellowish color tells us that the brightest stars that we're seeing here are sort of yellowish stars like the sun. We have no young, bright blue stars in this galaxy. And that means that this galaxy is old. It hasn't made new stars in a long time. And most elliptical galaxies are at least 3 or 4 billion years old and haven't formed any new stars since that time. Some look even older than that. Spiral galaxies, well, they're the spiral nebulae. They look like spirals. And when you see them from above or below, you do see the spiral arms. Our Milky Way, we don't see the spiral arms because we're looking at it from the edge. And notice also sort of a typical color here, that the center is a little yellowish, which tells us that tends to be older. There aren't a lot of new stars at the center of spiral galaxies. There are some, but not a lot. But in the spiral arms, they're mostly bluish-white, saying that those are made out of very young stars. And often in spiral galaxies, we can see star-forming nebulae as well. So we know that they're currently making new stars. When you see a spiral galaxy from the side, they tend to be long and thin. They look like a pancake or something seen from the side. You can notice that some of these have bulges like our galaxy. Some don't appear to. And all of them have this, what Curtis called the obscuring band, but have a lot of dust that block our view when we see it from the side. When we look from above, the galaxy is pretty thin, so the dust doesn't have a lot to block, but when we look at it from the edge, we're looking through a lot of dust and it blocks a lot of light. So here's a picture of a spiral galaxy called the Whirlpool Galaxy, or Messier 51. And it's the galaxy. There are actually two galaxies here. There's the big one that takes up 2/3 of the left, and there's a second one on the right. And the whirlpool itself is the spiral one. And you can see lots of young stars, lots of bluish colors, white colors meaning young. And here the artists who put this picture together emphasized the star-forming nebulae, so they're the bright red patches in this picture. That's where new stars are being formed in the whirlpool. You can also see that one of the whirlpool's arms extends, the dust in it extends beyond what we can see and covers up some of the light in this neighbor galaxy, which is otherwise mostly an elliptical. So most of the dust you see in that second little galaxy is dust from the whirlpool, not dust in that galaxy. A lot of spirals, about half of them, have bars like the Milky Way galaxy. Some of the bars are small, like the one in the upper right here that looks sort of like a TIE fighter. Sometimes the galaxy is mostly bar, like the two on the bottom. Now there are also some galaxies that appear to be a hybrid of a spiral and an elliptical. Sometimes these are called lenticular galaxies because they look like two contact lenses put together. On the top here is a picture of a galaxy called the Sombrero Galaxy. In the Sombrero, you see a disk with dust in it, but you also see something that looks like a ginormous bulge that is as big as the spiral galaxy itself. So that looks like a combination of a spiral and elliptical. And on the bottom, you have yellowish light from what looks like an elliptical galaxy with what looks like a disk that's been warped. It looks like a pancake that's kind of bent in the middle. And so this is telling us that there's something different happening in these galaxies. We will come back to them in the mini lecture on galaxy collisions. The final major type of galaxy is called an irregular galaxy. These have no regular shape. That's where they get their name. Here you can see a galaxy in the lower left that looks sort of like a squarish diamond. The upper galaxy here is a neighbor of the Milky Way called a Large Magellanic Cloud. And again, you see there's no definite spiral structure. There's no definite disk to it. It's just sort of irregular shaped. And then there's another irregular galaxy on the lower right. A lot of irregular galaxies have a lot of gas and a lot of dust and a lot of young stars. Some of them don't, but most do. Now, often galaxies are classified by their appearance using something called the Hubble Sequence. Edwin Hubble came up with this. He thought that this was telling us how galaxies form and change over time. We now don't believe that that's a proper interpretation. The Hubble sequence goes from the most round elliptical galaxies on the left, and then you continue on elliptical galaxies, but they get more and more elliptical until you get to a split. And the split puts barred spirals on the bottom and regular spirals on the top, and it ranks them on how tightly wound their spiral arms are. So you see that in say an SA galaxy. It's got spiral arms that are tightly wound around the center, while an SC galaxy looks like it's unwound a little bit. The barred galaxies, it's the same sort of thing. If the spiral arms at the tips of the bar are tightly wound, it's an A. If they're loosely wound, it's a C, and in between it's a B. Those lenticular galaxies would be the S zeros and SB zeros, things that look like they have disks but also look kind of elliptically. And then the irregular galaxies just sit off on the right. Really what the sequence is telling us is how much dust and gas each of these galaxies has. Ellipticals have very little dust and gas, and as you go to the right, you get more and more dust and gas until you get to the irregulars, which have the most of all of them. Our Milky Way is a barred spiral of type B, so it would be an SBB galaxy. And let me emphasize, this is a classification scheme. It's not a pathway over which galaxies change. So here's a summary of galaxy types. Ellipticals have old stars. They're sort of yellowish in color because of that. They don't have any young, hot blue stars. They rarely have gas and dust in them. And their shapes, they're fairly much round. The oval counts as round. And they're fairly smooth. There are no obvious features to them. Spiral galaxies, they have both old stars and young stars. They tend to have dust and gas, sometimes a little, sometimes a lot. And their shape, they're these disks, frisbee shapes with spiral arms and often with bulges. And finally, the third major type of galaxies, these irregulars, they have both old and young stars. They usually have lots of dust and gas, but they don't have any regular shape. They're sort of amorphous, blobby type galaxies. Galaxies, they tend to be gregarious. They tend not to be alone. They tend to have neighbors. Here's a picture taken by the Hubble Space Telescope of a group of galaxies called Stephan's Quintet. There are 5 galaxies here, 4 of which are all together in space. That means that these 4 galaxies are all about the same distance away from us, and they're so close together they're interacting. We'll talk about that in a later mini lecture. The 5th galaxy is closer to us than the others. Although it looks the same size, it's actually smaller and closer to us. Often, galaxies will have satellites, kind of like moons, except our moon is solid. These satellites are also galaxies, so made out of their own stars. But these little galaxies tend to orbit big galaxies. Here's a picture of the Andromeda Galaxy. It's a spiral galaxy that we're seeing almost, but not quite edge-on, so we don't have a good view of the spiral arms. You can see the dust pretty well. It has two small galaxies that are satellites that we can see here in this picture. The one on the top is called NGC 205. NGC is for the New Galactic Catalog. It was a catalog put together in the 1800s. The lower galaxy, which is very dense and tight, is called Messier 32. And again, it's a satellite of Andromeda. Andromeda has lots of other satellite galaxies that tend to be even smaller, and so they're very faint and hard to see, and they are further away than this picture allows us to see. The Milky Way has at least a dozen satellite galaxies. Most of them are small and faint, and you need a telescope to see them. But the two largest ones are called the Large Magellanic Cloud and the Small Magellanic Cloud. The Large and Small Magellanic Clouds are only visible from the southern hemisphere. But if you go down to South America, they look like little clouds in an otherwise clear sky. I've seen them. The Large Magellanic Cloud is about 186,000 light years away. Both of these orbit the Milky Way. Here's a color picture of them. Again, showing, you see from the red and pink and blue and white, that they have lots of star-forming nebulae. They're making lots of young stars. They have older ones as well. Big galaxies tend to have satellite galaxies, and galaxies themselves tend to be in what we call groups. Groups of galaxies can contain just a few galaxies. Here's one that has sort of 2.5 big galaxies. There are probably some fainter ones around. Here's a group of galaxies that has a few dozen. You can see 4 big ones and a handful of smaller ones. Typically, a few to a few dozen galaxies. So our group of galaxies is called the local group. Here's kind of a map. The MPC means megaparsec, and that means 1,000,000 parsecs. And since 1 parsec is 3.26 light years, this is about 3.26 million light years across. The two biggest galaxies are us, the Milky Way, and the Andromeda Galaxy, Messier 31. In pink are little tiny dwarfy faint galaxies. You can see that both the Milky Way and Andromeda have several of these. The other green galaxy, Messier 33, is the Triangulum Galaxy. And you see the Large and Small Magellanic Clouds there in blue. Basically, we and Andromeda are the two big boys in the block, and the other galaxies tend to orbit around us. Now, some galaxies belong to a cluster. We do not live in a cluster of galaxies. We live in a little group. And after our group, which is about 3 million light years across, there are several million light years until the next little group of galaxies, which is about the same size. But sometimes you have clusters of galaxies. Here's a picture of one taken by the Hubble Space Telescope. And notice that clusters of galaxies can have hundreds or even thousands of galaxies in them. And each of these galaxies is like the Milky Way, consisting of billions of stars separated from its neighbors. Although if we were in a cluster like this, we would have lots of galaxies that we could see in our sky. This cluster here is about the same size as our local group of galaxies. So about 3 or 4 million light years across. Instead of just having 2 big galaxies and a few small ones, this cluster in the same volume of the universe has thousands of galaxies and dozens of giant galaxies. I'll notice that most galaxies and galaxy clusters tend to be elliptical, whereas most galaxies and galaxy groups are spirals and irregulars. Why is that? Well, see Minilecture 4 for the answers, but I'll give you a hint. Galaxies collide. So in summary, let me bring back up this summary of the types of galaxies. I would like you to know these facts about galaxies. I'd like you to be able to identify a galaxy if I show you a picture as an elliptical or a spiral or an irregular. Know what kind of galaxy we live in. The Milky Way is a barred spiral galaxy. And know that galaxies tend to be gregarious. They live in groups or clusters of galaxies. Clusters of galaxies can have thousands of galaxies, mostly ellipticals, while groups of galaxies just have a few to maybe a couple dozen galaxies, mostly spirals. All right, go ahead and complete the response to this mini lecture and then head on to mini lecture number 3.